Okay, so I hope what we're working on today is going to feel mostly like a review. Should be something that you saw a little bit of in Algebra 1, but we're going to work on simplifying radicals this week. When we multiply numbers and take the square root of them, it's called a geometric mean. So it's a little bit different than adding numbers and dividing. So it's kind of the first thing we're looking at in the next chapter. So I want to double back a little bit and make sure we understand the idea of simplifying radicals. So one of the things you want to do off to the side somewhere is maybe have some of these numbers written down. These are your perfect square numbers. In other words, 1 squared is 1. Not a big deal when it comes to that one. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And if you have these committed to memory, even better. But if you can just write them down somewhere and have them as a quick reference. So when I see the number 49, I want that to jump off the page to me. Okay. These perfect square numbers. 9 squared equals 81. 10 squared, of course, is 100. 11 squared is 121. And I'll stop it now for now at 12 squared, 144. So these numbers here should jump off the page at me. 1, 4, 9. When I see them, I want to make sure I recognize them right away as a factor of a number. So I look at this first radical here and I see the square root of 75. The idea here is to find in these perfect squares what's the biggest perfect square that divides evenly into 75, and I find it here. Okay, so what I do with 75, let's see. So when I have the square root of 75, I find that 25 is a factor of 75. So I'm going to break this down like when you factored numbers back in elementary and middle school. I'm going to break this down into the square root of 25, that perfect square. I always want to extract that. And square root of 25 times the square root of 3. Okay, I'm allowed to say that if I have the square root of 25 times the square root of 3, both living under the radical, that's equal to the square root of 75. So now we can take that square root of 25 and simplify it. It's just 5. So this pairs down to 5 root 3. So if you had a calculator handy and you put in square root of 75 on your calculator, it's going to equal the same thing as 5 square root of 3. Okay, so the next one's real easy. Square root of 16, that's a perfect square. There's not a whole lot we need to do with that. So square root of 8, square root of 8 is not too bad. It's not a very big number, so we don't have to look very far before we find the square root of 4 would divide into 8 evenly. And that's times the square root of 2, right? So I have these two numbers that still always take me back to my original. 4 times 2 is 8. So I take the square root of 4, that's 2, and then we still have 2 living under the radical, 2 root 2. Okay? Square root of 18, let's think about that. We go down the list. 4 doesn't go into 18. 9, right away. Square root of 9 times the square root of 2. That gets me to my 18. So this would just be 3 square root of 2. Okay. Next one we have square root of 32. Let's think. 4 goes into that. Okay, 4 would definitely go into that, but it would be 4 times 8, and we just saw that 8 simplifies, so 4 is probably not the biggest perfect square. All right, 16 times 2 gets us to 32, so that's the one I want. I'm going to have the square root of 16 times the square root of 2, and that gets me to 4 square root of 2. Okay, square root of 12. All right, what's the biggest number that goes into 12? That's a perfect square. That would be square root of 4 times the square root of 3. Square root of 4 is 2. We can take that square root, and we're left with 2 root 3. So try to, when you're working through these, go through them step by step. Okay, we get a repeat of square root of 8. We already saw that one. Okay, 108, kind of a tricky one. All right, probably not a number we have right off the top of our head. Does 4 go into that? Yeah, I think it does. Okay. But I think we can probably get to a bigger number, right? 4 goes into 100, 25 times, so probably 4 times 27. But remember, think about 27, right? That's a 9 times a 3. So we can probably find a bigger number than 4 that goes into the 108, right? So let's see, what do we have next? We got 9. That doesn't divide into 108. Then what do we have after that? 16. Does 16 divide into 108? And 16 does not divide into 108. So what's our next one? 25, definitely not. Okay, 36. That's an interesting one, right? 108 divided by 36. If you have a calculator handy, probably have one right on your computer, right? Take 36 and see if it divides into 108, and you'll see that it does, right? 36 times 3 is 108. So we want the square root of 36 times the square root of 3. So this would be 6 square root of 3. Okay? And that's what would have happened if we if we did 4 times 27. We'd get the same thing, right? We'd have the square root of 9, square root of 4, and that still gets us to our 6 square root of 3. Okay, so the next few, we're going to find the same perfect square repeated times. So 125, which one of those perfect squares goes into that evenly? Hopefully you notice right away that right, 25 goes into 125 5 times. So we take the square root of 25 times the square root of 5. Remember, these two numbers that live under the radical, to start, if we go step by step, always have to get us back to the original number. 25 times 5 is 125. So I have 5 times the square root of 5. And we leave it. Okay? We get 25 in this one again. Right? Hopefully you're liking these repeated numbers patterns. 25 times 2. Right? We have square root of 25 times square root of 2. So we take that square root of 25, perfect square, square root of 2. Okay? 175. 25 goes into that as well. We got 25 times 7. Okay? So that's 5 square root of 7. Okay? 28, not a very big number. So by the time we get to 16, we know it has to be something smaller. 4 goes into 28 evenly 7 times. So this is where some of you have your calculator handy. Like some of you sometimes, will mix up, 27 dividing by 9 and 28, what divides into different numbers, since you don't do that regularly. So have your calculator handy and double check your arithmetic and make sure that this works out. So that's 4 times 7. That would be 2 square roots of 7. And you can always check your work with your calculator. I can take 2 times the square root of 7 and see if I get the same decimal as when I do the square root of 28. Okay? All right, so I want you to try 17, 18, 19, and 20 on your own. Let's start with 17. Tell me what you get. Okay, so hopefully with 17, you saw that we can break that into the square root of 9. That's our perfect square. Times the square root of 5. Nothing's going to come out of 5, so this would be 3 square root of 5. Hopefully you got that one right. Let's try number 18 now. Okay, so 18 is another sneaky one. If we tried 9, if we had square root of 9 times square root of 8, that might still get you there. But the most efficient way would be to use the square root of 36. Then we're leaving a 2 under there. Anytime you see a number like that, 8, a previous problem that we did, we know it's going to break down further. So this would be 6 square root of 2. Hopefully you got that one right. Okay, let's try number 19, square root of 20. So hopefully you saw square root of 4, biggest perfect square that goes into 20, times the square root of 5. So this would be 2 square root of 5. And the last one, square root of 150, kind of like these guys up here. Okay, what's the square root of 150? Okay, so hopefully you broke that down into the square root of 25 times the square root of 6. 5 square root of 6.